Hello, geometry students. Welcome to our 9.1 through 9.3 notes. In this lesson, we're going to be talking about three different transformations. We're going to be talking about reflections, translations, and rotations. So let's start with talking about a reflection. And when we have a reflection, we always will be talking about a reflection in a line. We don't say a reflection over a line. We say the reflection in a line, just like you look at your reflection in a mirror. We're going to be talking about reflecting points in a line. So a reflection in a line is a function that maps a point, and that point we're going to call the pre-image. So that point is called the pre-image. All right, and so a reflection in a line is a function that maps a point called the pre-image to its image, such that, number one, if the point is on the line, then the image and the pre-image are the same point. Let's look at an example here. Take a look at this point A. The pre-image point is A. Notice that A is on the line of reflection, so that means that its image, A prime, is actually the same point. So the image point, the pre-image and the image are one and the same if the point is on the line of reflection. But then number two says, if the point is not on the line, then the line of reflection is the perpendicular bisector of the segment joining the pre-image to its image. So let's take a look at this example. Here we have a pre-image point A, and its reflection is A prime, and you'll notice that if we draw a line segment from the pre-image point to the image point, then we can see that K, the line of reflection, is the perpendicular bisector. Let's go ahead and put a perpendicular segment or mark. Well, that's not very big. You can't see that. Let me fix that. Let's go ahead and put a perpendicular segment on there. Okay, so this line of reflection K is the perpendicular bisector of a segment that would connect a pre-image point to its image point. Okay, so let's take a look at a couple of examples. Let's sketch the reflections in the given line. So I'm going to actually have us start with example B here because it's a little bit simpler one, only because we're reflecting in a horizontal line, and so that's going to be easier to do. So we're going to take and I think to make this a little bit easier, so I'm going to zoom in a little bit, make this a little bit bigger. Okay, so what we're going to do, we have triangle JKL, and we're going to find points J prime, K prime, and L prime, and then sketch the triangle that would be the reflection in the line M. So let's start with point J, and you'll notice that J is on the line of reflection, so that means J and J prime are actually the same point. Okay, so that was pretty easy. Now, let's take a look at L. We need to find where to place L prime such that if I draw a segment from L to L prime, this line of reflection M is the perpendicular bisector of that segment. So we're just going to eyeball this. It's not going to be perfect, but let's put L prime right about here. Now, if I were to draw a segment from L to L prime, then you can see that this line M is the perpendicular bisector. It's the perpendicular bisector of a segment that connects point L, pre-image point, to its image point M. Then we're going to do the same thing with K. So we need to kind of eyeball. We need to place K such that the line M would be the perpendicular bisector of a segment that connects K to K prime. So I think K prime needs to be right about here. Now we could get rulers out and be really be a little bit more specific here, but I'm going to call this point K prime. And again, if I draw a segment from K to K prime, then the line M, the line of reflection, should be the perpendicular bisector of a segment that connects K to K prime. So now what we're going to do is we're going to connect the dots. We're going to draw our triangle. So if you draw a triangle J prime, L prime, K prime, okay, then again, this is a drawing by hand, so it's not going to be perfect. But you can see that what we've done is we've drawn a triangle that is the reflection of triangle JKL in line M. Okay, so let's try another one. Let's take a look at example A. So let's start with point A. And so what I need to do is place A prime in such a place such that line K will be the perpendicular bisector of the segment that connects A to A prime. So we're just eyeballing this. So I think A needs to go right about here. We're going to call that point A prime. So that is A prime. And again, if I connect A to A prime, then line K, this line should be the perpendicular bisector of the segment that connects A to A prime, okay? Now, the same thing with B. We need to place B prime in a spot such that line K would be the perpendicular bisector of a segment that connects B to B prime. So again, that would be right about, again, I'm just eyeballing this, so right about here. So that's B prime. And again, if I connect B to B prime, if I've placed it in the right spot, then the line K would be the perpendicular bisector of the segment that connects B to B prime. And then we're going to do the same thing. We're going to place C prime right about here, right about there. Okay. Okay, that's C prime. Oh, you know what? I don't like where I placed that. I'm going to move it over just a little bit. Right about here. Let's call that C prime. Okay, and again, the segment from C to C prime should be bisected in a perpendicular way by the line of reflection, line K. So I'm going to put a right angle here and tick marks to show that it's the line of reflection is a perpendicular bisector. So now when we draw a triangle, okay, we can see that we've taken triangle ABC and we've reflected it in line K. All right, so let's try one more example. Let's take a look. Oh, hold on. Okay, let's try example C. Now this one's going to be a little bit different because we can see how we'll have P flipping over line N to the right, and then Q, R, and S will all flip over to the left. So I'm going to start by placing P where I think it ought to be. So right about here, we're going to call that P prime. And then Q prime would be over here, Q prime. And again, I'm just eyeballing where to place these image points such that the line N, which is our line of reflection, is the perpendicular bisector of a segment that connects a image point to its pre-image point to its image point. So hopefully I've done the same thing with Q. Okay, and then point S would be right about here. There's S prime. And then R prime. So here's R prime. I need to flip it over line N, so it'd be right about here. Okay, and so now when we draw the new quadrilateral, we can see how it reflects in the line N. Okay, oops, what did I just do? In the line N, and it kind of flips onto itself, part of it. Okay, so you'll have some practice like this in class tomorrow, and so or next time. So when you go to draw a reflection, when you sketch it by hand, you want to try and just place those points in such a way that the line of reflection is the perpendicular bisector of a segment that connects a pre-image point to an image point. Okay, so now let's take a look at an example where we're going to be drawing some reflections in the coordinate plane. In other words, reflections that are actually done on an XY plane axis. So these are a little bit easier to do than drawing them freehand. So let's take a look at this example where we're going to draw a trapezoid RSTV that has coordinates, here are the coordinates for R, S, T, and V. We're going to graph that trapezoid, and then we're going to graph its reflection in the line y equals -1, and then another reflection in the line x equals -1. And you'll see that this is a little bit easier to do. So let's start by plotting these 4 points. So we're going to plot point R at 1, 1. That is point R. And then we're going to plot point S at 0, 4. S. And then we will plot point T at 4, 4. So I'm going to start at the origin, move 4 to the right, and up 1, 2, 3, 4. So that's where point T would be. There's T. And then point V is at 3, 1. So from the origin, go right 3 and up 1. And that's point V. All right, so there's our trapezoid. And so now let's do the two reflections. Our first reflection is going to be in the line y equals -1. Well, remember that the line y equals -1 is a horizontal line that passes through -1 on the y-axis. So let me go ahead and sketch that line. So this is the line y equals -1. Okay, and so let's draw the reflection in that line, y equals -1. So this is a little easier to do. So let's just start with r. Notice that r is 2 units above the line, so r prime needs to be 2 units below the line. So r prime would be, oops, let me do it, I'll do this color. R prime would be right here, and then v prime would be also 2 units below the line. Here's v prime. T is, let's see, T is 1, 2, 3, 4, 5 units above the line. So T prime needs to be 1, 2, 3, 4, 5 units below the line. Okay, so this is T prime. And then S prime needs to be on, it's on the y-axis, and it is also 5 units below the line. So 1, 2, 3, 4, 5. Okay, so there's S prime. Okay, so when you draw the trapezoid, I think you can see the reflection. It looks like we have taken trapezoid RSTV and we flipped it over the line y equals -1. Now let's do the same thing. Let's do a reflection in the line x equals -1. So x equals -1 is going to be a vertical line that passes through -1 on the x-axis. So now what we're going to do is we're going to, let's just start with S. S prime, S is 1 unit to the right of that line, so S prime would be 1 unit to the left. So here's S prime. Okay, and then T prime, which is 1, 2, 3, 4, 5 units to the left of our line. So 1, 2, 3, 4, 5 units to the left. Let's see, did I get my left and right mixed up? I think I did. T is 5 units to the right, so T prime needs to be 5 units to the left. So here's T prime, and then go ahead and flip R and V over that line, or reflect it in the line. So R prime would be here, and then V prime, let's see, 1, 2, 3, 4, is 4 units, 1, 2, 3, 4, and there is V prime. Okay, so draw your trapezoid, and once you're done, you should be able to see the reflection in the line x equals -1. Okay, so let's generalize this a bit. Let's talk about reflections in the coordinate plane. And to make it a little bit simpler, we are going to just be specifically talking about reflections in the x-axis, reflections in the y-axis, and then reflections in the line y equals x. You'll recall that this is the line y equals x, okay? So if we take a point and whose coordinates are x, y, and we reflect it in the line in the x-axis, it just flips on the other side of the x-axis. So you'll notice that if the coordinates of that point are x, y, those are the coordinates of the pre-image, then the coordinates of the image are going to be x opposite of y. Notice these 2 points have the same x value, but they have opposite y values. When we reflect in the y-axis, if we have a pre-image point x, y, then the image point p prime, they're going to have the same y value, but opposite x values. So in other words, if x, y are the coordinates of the pre-image point, then opposite x, y are going to be the coordinates of the image point. Okay, and then when we reflect in the line y equals x, what happens is if x, y are the coordinates of the pre-image point, the image point, we're just going to take x, y, and switch them, okay? And so the coordinates of p prime will be y, x. You might recall that when we reflect in the line y equals x, we're talking about an inverse function. And an inverse function, I don't want to get too in the weeds here, but an inverse function is where the domain and range switches places. The x becomes y's and the y's become x's. So again, if you're going to reflect a point in the line y equals x, just take the coordinates and switch them. Okay, so let's take a look at some examples of some reflections in the coordinate plane. So in this example, we're going to take triangle ABC with these vertices. We're going to reflect that triangle in the x-axis, and we're also going to reflect it in the y-axis. So let's start by graphing triangle ABC. So point A is at -3, 3, so let's plot that point. So 1, 2, see, from the origin, go 3 left and up 3. So there's A. Point B is at 1, 2. And then point C has coordinates 2, 0. 2, 0. So there's our, oops, not C prime. I didn't mean to do that. It's just C. So let's go ahead and draw triangle ABC. Okay. All right, so the first reflection we're going to do is we're going to reflect in the x-axis. So let's just follow the rule. When you take a point and you reflect it in the x-axis, xy becomes x opposite of y. So in other words, these 3 points are all going to have the same y value, the same x value, so -3, 1, and 2, but they're going to have opposite y values. So this first point, -3, +3, is going to become -3, -3. Just change the sign on the y value. All right, 1, 2 will become 1, -2. And 2, 0 stays 2, 0 because the opposite of 0 is 0. Okay, so let's go ahead and plot these 3 points. And I'm going to plot them in a different color. So I'm going to plot the point A prime at -3, -3. Okay, there's A prime. And then I'm going to plot B prime at 1, -2. So there's B prime. And then C prime is going to be the same as C. Notice remember we're reflecting in the x-axis. C is on the x-axis, so that means C and C prime are the same point. All right, so we'll draw that triangle, and I think you can see the reflection in the x-axis. Okay, so now let's go ahead and take our original triangle and reflect it in the y-axis. So following the rule, when you reflect in the y-axis, the y values stay the same, but we have opposite x values. So A becomes A with points coordinates -3, 3 becomes A prime, which has coordinates +3, 3. Again, keep the same y value, but change the sign on the x value. So B prime would be -1, +2, and C prime would be -2, 0. So let's plot those 3 points. So I'm going to start with A prime, which is at 3, 3. So from the origin, I'm going to go right 3 and up 3. So there's A prime. Okay, B prime is -1, 2. -1, 2. So B prime is right here. And then C prime is at -2, 0. So right here. Okay, and then I'm going to draw that triangle. And you should be able to see the reflection in the y-axis. Okay, and then the next example says, graph quadrilateral JKLM with these vertices, and then graph its reflection in the line y equals x. So the first thing I'm going to do is I'm going to actually draw the line y equals x so we can see the line that we are reflecting over. Okay, so that's the line y equals x. We're going to flip over that line or reflect in that line. So the rule for, well, let's go ahead and graph our quadrilateral. So let's graph these 4 points. So we'll start with J. J is at 2, 2. It's right on the line of reflection. Okay, K is at 4, 1. There's K, and then L is at, let's see, 3, -3. There's L, and then point, oops, why do I keep putting a prime on there? Let me erase that real quick. And then point M is at 0, -4. So that's M. Okay, so there's our quadrilateral JKLM. Okay, now, when we reflect it in the line y equals x, let's follow the rule. All we have to do is take the x and y values and switch them. So J with coordinates 2, 2 is still going to be the point 2, 2. Okay, it's on the line of reflection, so J and J prime are the same point. K becomes K prime, it would be 1, 4. L would be -3, 3. And M prime would be -4, 0. So let's go ahead and plot those 4 points. So J prime is the same as J. So J and J prime are the same point, okay, because J is on the line of reflection. Point K at 1, 4. Here's K prime, and then we're going to plot L prime at -3, 3. So L prime, and then finally M prime is at -4, 0. 1, 2, 3, 4. There's M prime. Okay, so then we're going to draw our quadrilateral. And I think you can see the reflection. If you could take your piece of paper and fold it along the line y equals x, then K should land on K prime, L should land on L prime, and M should land on M prime. And of course, J and J prime are on the line of reflection, so they would match up. All right, so that's reflection. So the next thing we're going to do is talk about our second transformation today, and that we're going to talk about translations. Okay, the definition of a translation says it's a function that maps each point, and by each point we mean each pre-image point, to its image along a translation vector. So remember what a vector was. A vector indicates two things, distance and direction. Okay, so a function that maps each pre-image point to its image along a translation vector such that each segment joining a point to its image has the same length and as the vector and is parallel to the vector. So for example, let's take a look at pre-image point A and its image A prime. Now, how did we determine that A prime is right here? Well, it was defined by this translation vector K. So here's the translation vector K. So what we do is we take A and we move it the same distance as K is, the same length as translation vector K, and also parallel to that vector. All right, so A, it's like if A were here, we would slide it here. So the translation vector determines the distance and the direction that each point is translated. Okay, so let's take a look at an example. We're going to draw a translation of the figure along the translation vector. So P, Q, and R are going to be determined by this vector. In other words, every point we're going to have to mimic this motion of sliding every point the same distance and the same direction. So if I were to take point P and I were to translate it, and we're just roughing this by hand. Oops. So, okay, what I'm trying to do is I'm trying to mimic moving P this distance and this direction. So when I do, then my new point would be P prime. Okay, and I'm going to do the same thing with K. I want to mimic this movement right here. So I'm going to move K. I'm going to try and mimic that translation vector. We want the same distance in the same direction. So this would be Q prime. And then R prime would be determined again by this translation vector. So we want to slide R the same distance and parallel to the translation vector. Okay, so again, this is a freehand drawing, so it's not going to be perfect. But here's PQR, P prime, Q prime, R prime rather. And so what we've done is we've taken all three of these points and we took every point, we translated them the same distance in the same direction to create our image triangle, P prime, Q prime, R prime. Let's do the same thing with this trapezoid. So what we want to do is we want to translate every point using this translation vector. So every point should slide the same distance and in the same direction. So again, we're just doing this freehand, so it's not going to be perfect, but I'm going to try and slide A. That looks about right. Okay, so A prime would be right about here. Okay, I'm going to do D prime next, so I'm going to slide it the same distance and the same direction. So D prime would be right about here. And then the same thing with C prime, trying to mimic that same distance, same direction. So C prime would be right about here, and then D prime, or B prime, rather, right about here. Okay, B prime. Okay, and then draw the quadrilateral. So it appears that we have taken this pre-image and we have just translated it by just translating every point the same distance in the same direction as determined by this translation vector. Now, you can imagine that translations in the coordinate plane are going to be a little bit easier than trying to freehand them. So let's take a look at the rule for translations in the coordinate plane. If we're going to translate a point P along a vector AB, remember this is a vector represented in component form, where this represents a horizontal move and B represents a vertical move. So if our pre-image points have coordinates x, y, and we're going to translate that point along the vector AB, that means we would just add A to the x value and add B to the y value. So let's look at this example where we're going to translate triangle EFG with these vertices along the vector 2, 5. So let's start by graphing the triangle. So we're going to plot those points. So let's start with point E at -7, -1. Okay, so here's E. Okay, and then G is at, or F is at -4, -4. So go left 4. Let's see, 1, 2, 3, 4, down 1, 2, 3, 4. So here's point F. And then pre-image point G is at -3, -1. So there's G. So there's our triangle. Now, we're going to translate it along this vector. So we're going to use the rule. Every point x, y will become x plus 2, y plus 5. In other words, we just need to add 2 to the x value and add 5 to the y value. So that means that point E, -7, -1 will become, let's see, -5, 4. -5, comma 4. Okay, and then -4, -4, when I add 2 to -4, I get -2. When I add 5 to -4, I get 1. And then G becomes G prime with coordinates -1, +4. Because -3 plus 2 is -1, and -1 plus 5 is 4. Okay, so let's plot those points. So E prime is -5, 4. So 1, 2, 3, 4. So here's E prime. Okay, G prime, or excuse me, F prime is at -2, 1. So here's F prime. And then G prime is at -1, 4. So there's G prime. Okay, so we can see that our image triangle is the result of taking every point got shifted 2 to the left and up 5. 2 to the left, up 5, 2 to the left, up 5. The last transformation we're going to look at today is a rotation. Now this definition is a little bit wordy, but let's work through it, and then as we put it into practice, it'll start to make a little bit more sense. So here's the definition of a rotation. It's a function that maps a point, meaning a pre-image point, to its image by rotating the point about a fixed point called the center of rotation, rotation, okay, through an angle of x degrees such that, number one, if the point is the center of rotation, then the image and the pre-image point would be the same, okay, and number two, if the point is not the center of rotation, in other words, the pre-image point is not the center of rotation, then the pre-image and image point are the same distance from the center of rotation, and x degrees is the angle formed by the pre-image point, the center of rotation, and the image. Okay, so now let's break that down and see what that means. So let's look at this example of pre-image point A that's going to be rotated about the point C. So C is our center of rotation, and we're going to rotate it 120 degrees in the counterclockwise direction. So that's one thing that we need to make sure that we understand. All the rotations we do will be in the counterclockwise direction. That's this way. I like to think of it as a left turn of a steering wheel, or it's called counterclockwise because it goes in the opposite direction of the hands on a clock. So that's why we call it counterclockwise. So all rotations that we do will be counterclockwise unless otherwise stated. Okay, so we're looking at point A. A prime is the image of pre-image point A after 120 degrees rotation about point C. So we've taken A, we have rotated it from A to A prime. Okay, now let's look at the definition. So the point is not the center of rotation, then the pre-image and the image are the same distance from the center of rotation. So here's our center of rotation. You can see that the pre-image point and the image point, see these tick marks? They're the same distance from the center of rotation, and the angle formed by pre-image point to center of rotation to image point, that angle is a 120 degree angle. Okay, so we've already stated, but let's state it again. The direction of rotation will always be counterclockwise unless otherwise stated. Okay, so if you see a rotation, let's assume that it's a clockwise rotation. So now let's take a look at an example of drawing a 90-degree rotation of triangle ABC about point P. So none of these are the same as the point of rotation because this is the point we're rotating about. So here's how we're going to do this. And again, we're going to draw this freehand, so it's not going to be perfect. But what I need is I need to place A prime such that the distance that A prime is the same distance from P that A is, and the angle formed going from A to P, from the pre-image point to the center of rotation to my image point, forms a 90-degree angle. So I think A prime needs to be right about here. And again, this is going to be rough. Okay, so A prime, let me just see if A prime should be the same distance from P that A is. So I'm going to put a tick mark here and a tick mark here. And the angle formed as we go from A to center of rotation to A prime should be a right angle. Okay, so it looks like we have rotated A to A prime 90 degrees about point P. So now let's try the same thing with B. So I need the distance from B to P to be the same as the distance from P to B prime, and I need B to P to B prime to form a right angle. So I think I've got B prime in about the right spot. So here's B prime, okay? And then C, again, I need the distance. Let's see, I need a new color. How about blue? Okay, I need the distance from C to P to be the same as the distance from C to P prime. That looks about the same. So C prime ought to be right here. And the angle formed as we go from C to P prime should form a right angle. Okay, so when we do that, we can draw our triangle, and it looks like we've taken triangle ABC and we have rotated it 90 degrees to create triangle A prime, B prime, C prime. Okay, so that's drawing a rotation freehand. It's going to be a little bit easier when we talk about rotations in the coordinate plane, and we're even going to make this even simpler. All of our rotations will be about the origin. So we're going to talk about rotations in the coordinate plane about the origin, okay? So what we can do is we can learn the rule, and that makes it a little bit easier. If we're going to do a 90-degree rotation in the clockwise direction about the origin, then every point xy will become opposite yx. So in other words, all we need to do is follow this rule, and that will automatically give us a 90-degree rotation about the origin. For a 180-degree rotation, x, y, just change the signs. They become opposite of y and opposite of x and opposite of y. And then for a 270-degree rotation, x, y becomes y opposite of x. Okay, so let's do an example. We're going to take a triangle PQR, which has vertices listed here. We're going to graph triangle PQR and its image after a 90-degree rotation about the origin. So we'll be following this rule where x, y, every point's coordinates x, y become the opposite y, x. So let's go ahead and graph our triangle first of all. Graph point P at 1, 1, and then point Q is at 4, 5. There's point Q, and then point R is at 5, 1. There's point R. Okay, so there's our triangle PQR. Now what we're going to do is we're going to rotate it 90 degrees about the origin, okay, and we'll place our points by following this rule. So 1, 1 would become, we switch the order, and then we change the sign on y. So that's going to become, 1, 1 will become -1, 1. 4, 5 will become -5, 4. And point R with coordinates 5, 1 will become -1, 5. So let's plot those points. So we've got -1, 1 is our point P prime. And then Q prime is -5, 4. Okay, so here's Q prime. And then R prime is at -1, 5. There's R prime. Okay, so what we've done is we have taken triangle PQR and we have rotated it 90 degrees about the origin. All right, so you'll get some more practice on this in class. If you have any questions, be sure and ask me, and I will see you when we're in class together again.